We present authoring motion cycles. Existing methods for authoring motion cycles require using general-purpose animation packages. They rely on complex mechanisms that make the process tedious, time-consuming, and restricted to experienced artists. We propose a system for the authoring of motion cycles that allow the intuitive creation of compelling animations in a short amount of time. The looping nature of motion cycles makes them especially appropriate for performance animation. Our system allows the user to act out several cycles of the motion. We propose an algorithm to analyze and extract a looping cycle from this imperfect input based on a new curve descriptor. We extend the recorded motion in the temporal dimension and detect similar areas. This allows us to extract several cycles that we use to form the final motion cycle. Several performances can be layered in order to compose complex motions. Here the user is adding rotation to the foot. We then introduce an interaction tool called MoCurves that allow the intuitive editing of all aspects of the motion directly in the viewport and while the animation is played. First, the trajectory can be edited by manipulating a 3D spline. Then, rotations and scales are represented by arrows that are directly editable. To edit time, the user can spatially move keyframes in the viewport, and we solve for an optimization-based time warping that conserves certain properties of the motion. It is particularly convenient for synchronizing different motions. Finally, we allow editing planar contacts by simply drawing a stroke. For cases where multiple elements are simultaneously in contact, we automatically adjust the motion in order to solve sliding effects, and we consistently move the root of the character. We now show results of motion cycles authored using our system. We allow using any type of device as input. Here is an example using the lip motion. These motion cycles were created by 5 different novice users in less than 1 hour. For all of them, this was their first character animation ever. We also show a result created using the HTC Vive. One can also use full motion capture suits. Here, our algorithm is applied on one single multidimensional curve representing the whole motion. In green, we show the cycle extracted from the blue input motion. We see that popping artifacts are removed. It also allows removing the eventual noise present in the input data. We finally show other results created using a mouse or a digital pen as a live capture device. These results were created by an expert artist. This flying animation was created in about 15 minutes. This eating motion cycle was authored in about 20 minutes. This juggling animation was created in about 35 minutes. We've considered limitations and hints for future work. A particularly interesting aspect is physical simulations. Our algorithm is able to extract a looping cycle from these very high-dimensional motions. However, the physical correctness is not conserved and the results may not look realistic anymore. integrating physical constraints into our algorithm would be a pertinent direction for future work. Thank you for your attention.